Okay, so a common question would be to ask maybe the product of two positive consecutive integers is 156. We can model this with a quadratic equation, okay? So we're going to write an equation in factored form because I see the word product, so I know that means I'm going to write factors, okay? And I'm going to have the factors equal 156, okay? I know you might be able to guess and check, but I want to show you how quadratics can help you solve it, okay? So I'm going to use two positive consecutive integers means that if I have the first number x, then I would multiply that by x plus 1. That's going to give me a number and the next consecutive integer. Okay? So what I'm going to end up with is x squared plus x minus 156 equals 0. Remember that when I'm doing solving, unless I can somehow take the square root, which in this case I can't, I have to get it equal to 0 to be able to either factor or use the quadratic formula. In this one, I can factor it pretty easily by just looking at it. If that's something that doesn't come as easy to you, then you might think about using the quadratic formula with a equals 1, b equals 1, and c equals negative 156. Personally, I know that 12 times 13 is 156, so I'm going to use x plus 13 and x minus 12. Okay, so I'm going to do x equals negative 13 or positive 12. Okay, so that means that the consecutive integers I can use would be negative 13 and negative 12 would multiply to give me negative 150 or positive 156, or positive 12 and positive 13 would also multiply to give me 156. I'm going to think about each of these as the solution for x, and then I have to think about the next consecutive integer. So in this case, negative 13 with negative 12 would be my two integers to be 156. And then in this case, if I think about 12 as my x, the next consecutive integer would be 13. So this is what it means when it says interpret the meaning, okay? When I get to this step right here, I'm not to the point anymore where this is my answer. Okay, I have to actually go in and think about it for a second, because negative 13 times 12 does not equal positive 156. This gives us two options for the first integer, and then we have to think about the pair that goes with it in our situation. Okay, a lot of times also quadratics are used when we're talking about the area. We have that the length is 10 meters more than the width, so we set the width at x and we set the length at x plus 10. And we know that the area, so x times x plus 10, length times width, equals 875. So this will give me x squared plus 10x minus 875 equals 0. And in this case, I was struggling coming up with some easy factors. You might be able to guess and check or to think about it for a little while and factor this, but I personally think I'm just going to use the quadratic formula to solve this problem. Okay? If you need help with the quadratic formula, you're going to go back and watch the quadratic formula video. I'm not going to step through the quadratic formula just to save you some time. So if you use these numbers in your quadratic formula, you should get that x either equals 25 or negative 35. And once again, we can't just leave this as our answer because remember we're talking about a pool. So is it possible for there to be a negative side length? No. So I'm not going to use this answer. The question is the dimensions of the pool. So I know that the width, which I used as x, could be 25. I know that the length is 10 more than the width, so that means that the length is 35. Okay? And then another popular example of quadratics is projectile motion. If you think about anything being thrown up into the air from a certain height or from being launched from the ground, it's going to go up and it's going to start going really quick. It's going to slow down. It's eventually going to reach a stopping point for a split second, and then it's going to slowly start going down, and then faster and faster and faster it's going to reach the ground. Okay? So that forms a parabola. we're going to give you the equation in this case for this parabola that models the height over a certain number of seconds that this stone is in the air. Okay? So the first question that we're going to answer is, how long was the stone in the air? So I want to know what t equals. I want to know the time that it was in the air. So I want to think about the part of the parabola that goes from here to here. I want to think about what that amount of time is. And what I notice is that this point right here, this root, is something with our x and 0 for our y. This number right here will tell us the seconds that we're at when the height is 0. That's what the root is telling us in this case. Because we know that t is our x, that's time, and h is our y, that's height. Okay? So I want to find this root of the equation. Remember, there's two roots. There's one over here, but in this case, this root's not going to help us. We want to just find the positive root. So I need to find negative 4.9t squared plus 17t plus 2.2, and I need to find it equal to a height of 0. We can put the equal 0 over on the left so that it's the same as the equation that we have up here. But more popular way to do it, and the way we've been doing it, is putting the 0 over on the right. Now this is set up for the quadratic formula. I'm going to use A, B, and C. And just like in the last example, I went ahead and did the work already so that you guys don't have to sit through that. If you need help with the quadratic formula, you're going to have to go back and watch that quadratic formula video or ask me for some help. So once I calculated that out, I got two solutions. I got x equals negative 0.124 and positive 3.5943. Like I said, we don't really care about this negative solution because we don't care about this spot on the parabola. We only care about right here. We care about the number of seconds when the height is 0. So we can answer this question by saying the stone was in the air approximately 3.6 seconds. Okay? All right. So let's answer the next question. When was it 10 feet tall? Okay? So if I go over to my graph, I see that I can look at a height of 10. And I look across my graph, I see that there are two spots on my graph where the height is 10. So I'm going to solve for 10 equals negative 4.9t squared plus 17t plus 2.2. Remember that we can also think about this as equal to 10 on the right-hand side, if that helps you. And I'm going to use the quadratic formula again, but I'm going to remember that I have to minus 10 from each side so that I end up with something equal to 0. So I'll get minus 7.8 equals 0. And then I use A, B, and C. A, B, C. I use those in my quadratic formula, and I get that there's two solutions, x equals 0.544 and x equals 2.925. These are the number of seconds. Each one is that what time the height is 10. Okay? And then the last one, this is going to be the easiest one for us, just because of the way that our equation's given to us. Our last question says, what was the height of the stone when it was thrown? Well, I've got my my graph over here to help me visualize that. I want to know when it was thrown. So that means I want to know at time equal to 0. So I'm going to look at this spot right here. I'm going to look at the y-intercept. And if you remember back to the last video, the y-intercept is easily found when something's given to us in general form, because I'm trying to find the height with time 0 plugged in. So if you'll notice, what's going to happen is this term's going to go away because it's going to be multiplying by 0. This term's going to go away because it's multiplying by 0, leaving us with the height at time of 0 is 2.2. Okay? That number right here is our C, and remember I told you that that's our y-intercept. So the height of the stone when it was thrown was 2.2 meters when stone was thrown. Okay? So before you come to class, you've got one of the area problems. I want you to set up a quadratic equation, and then I want you to solve that quadratic equation. Then I want you to answer the question, how much fencing does Susie need? Okay? So make sure you pay attention to that last question there, because that's going to be the important part. The whole reason we're doing this is to solve for that question. Okay? So our equation is going to help us figure out how much fencing she needs.